Hello and welcome to the video on Newton's laws examples. So all we really have to use for Newton's laws, and the most appropriate one is always Newton's second law. Newton's second law basically tells us that the resultant force is equal to the mass of the object times its acceleration. We usually write that as sigma f, so the sum of all the forces, the resultant force all in all, is equal to the mass times acceleration. So we'll be expected to solve some problems basically using that. Let's have a look at a couple of examples. So example 1 says, a body of mass 2 kilograms, subject to forces shown below. In the diagram, accelerates uniformly in the direction indicated. So it's accelerating in the x direction there, over to the right as we look at it, and this also asks us then to find that acceleration and the value of p. So p is a force if there is no vertical motion. You've got to be careful with vertical motion. I should have probably said y direction motion. Vertical always makes me think of gravity will be acting as well, but I will come to that in a bit. I should probably say y direction. So yes, basically I've got two lots of Newton's second law to do here. I've got to look in the x direction because I've got a force acting to the left and a force acting to the right in the x direction. And then in the y direction, I've got a force pulling it down, a force trying to pull it up. So, altogether then, if I apply Newton's second law in the x direction, then if I look at the sum of all of the forces, that should equal the mass times the acceleration. The important thing to note here is that, okay, so obviously that we've kind of got 6 newtons more to the right, but you should always define a positive direction. And it doesn't matter which direction you do is positive, to the right or to the left, it doesn't matter. I would always, however, strongly suggest going in the direction of the acceleration. So in this case, I would take to the right as positive. And therefore anything acting to the right would be positive, anything acting to the left would be negative. Well, in the x direction, those red forces here, that p and that 20 newtons, we don't really care about because they're not moving this thing from side to side. It's only the 10 and the 4. So Newton's law tells us that the sum of all the forces, so our positive force is 10 going to the right, our negative force is 4 going to the left, so 10 take away 4, the resultant of those forces, which we kind of know is 6 anyway, is equal to the mass of the object, 2 kilograms, times its acceleration. So hopefully you can see then, well, 6 equals 2 acceleration, so the acceleration of this object is going to be 6 divided by 2, which is 3 meters per second squared. So you can just rearrange that formula there to get your acceleration. Now they also ask us to find the value of that force p if there's no vertical acceleration, no y direction acceleration, then in that case then it doesn't move up or down, so it doesn't really matter which direction you choose as positive. I'll probably choose up as positive, you can equally choose down, it doesn't matter. And then Newton's second law in the y direction, excuse my writing, basically says that the sum of all your forces equals the mass times the acceleration. You can probably see already that p is equal to 20 newtons. They kind of cancel each other out, so there's no motion in the y direction. But we'll just go along with this just to show. So p is in the positive direction, minus 20 is in the negative, and that equals the mass, which is 2, times its acceleration, which is 0 in that direction. So in this case then, p minus 20 is 0, so p is equal to 20 newtons, to kind of cancel out that force going down. So we'll have to basically split this Newton's second law into two separate directions, in the x direction and the y direction sometimes, and then we'll have a look. So the important thing then is what we'll usually have is maybe things being accelerated by gravity. So in this case, the important thing to notice is that the force due to gravity is called weight. Remember, gravity is an acceleration, and Newton said that force is equal to mass times an acceleration. Mass times an acceleration. So the force then, which we call weight, is equal to the mass of the object times the acceleration, which is gravity. So mg is what we call weight, and that's always acting down. There we go. So if you know the mass of the object, then you know its weight. You just times it by 9.8, which is gravity. So let's have a look at an example here. This would be a basic lift type example, where you've got a box of mass 5 kilograms. There we go. Dangling on a rope, and it's being lowered vertically. So find the force in the rope when the box is lowered with an acceleration. So the acceleration downwards, lowered with that acceleration, is 4 meters per second squared. Okay, so to look at the forces now here, obviously pulling the box down is its weight, which is mass times gravity. So 5 gravities, 5 times 9.8. Tend to write it as g instead of 9.8 there. Then the force in the rope will hopefully, you've got a bit of an experience here in lowering things down. The reason that this box doesn't just clatter down towards the earth is because the rope is actually holding it up slightly. So even though it's been lowered down, there is a force in the rope. You're going to call it T for tension, which is a pulling force. It is actually pulling the box up slightly because it's slowing it down. It's stopping it from just free falling, basically. So you've got a force in the rope holding this box up a little bit. You've got its weight trying to pull it down, and overall it's accelerating downwards by 4 meters per second squared. So again, only vertical forces here. So if you apply Newton's second law vertically, I can say vertically now because I'm actually talking about gravity and everything. Tells me then that the sum of all of the forces equals the mass times the acceleration. I'm accelerating downwards, so I'll take down as my positive direction. There we go, so down is my positive direction. So any force acting down, that's my weight, 5g. Any force acting up is negative, which is the rope is actually pulling it up, and the mass times the acceleration. Mass is 5 kilograms times the acceleration, which is 4. Here we go. And so if I rearrange this, then I get T is equal to 5 gravities, take away 20, calculate the job, that comes out as 29 newtons as the force in the rope there. Thank you very much.